Assalamu alaikum, my dear students. How passing your days? Oh, fine. Previously, we discussed some question of general pathology, inflammation, chapter inflammation. Now, in continuation, we shall discuss about acute inflammation. What are the major components you know? Inflammation actually a defense or protective mechanism. There are fighter or defender against offender. The major components are vascular and cellular. Vasodilation, which leads to increase in amount of flow of blood and also increase the caliber of blood vessel. Increased permeability or vascular leakage. It enables solid particles as proteins and cellular components of blood to come out or to leave the circulation, and the cellular events here shall come out and go to the site of injury and eliminate the offending agents. We should not go outside in this lockdown situation. Students, train. In this picture, the train going where? It contains what? If we think it is going to the site of injury or site of offense where the offender are waiting, so the train may be exemplified with blood vessel. Yes, within it, it contains both fluid and solid components of blood. And the gatemen, the gate are closed, looking a bullet train, modernized bullet train. On its journey, gradually the doormen become prepared to leave someone. Firstly, small pore permit the fluid components. When the pore become or door become opened, reaching the site of injury, the solid part come out. So, again, the vascular and cellular events, the cells and molecules are in the journey going to the site of injury, and doormen in the train getting prepared to leave them. In this journey, firstly there are change in vascular caliber and flow. Characterized by transient vasoconstriction, vasodilation, exudation of protein-rich fluid, and stasis. After transient constriction, vasodilation starts. It starts in the arteriolar end, the arterioles. So, there is redness and also heat. Which are the hallmarks of acute inflammation. Due to increased caliber and flow, some exudation of fluid occur. The loss of fluid ultimately results in stasis. Arteriolar end normal in case of inflammation. Dilatation of the arterioles. Increased flow. There is leaking of fluid. And leaking of fluid ultimately leads to cellular stasis, and cellular stasis causes cell emigration, and subsequently the next event starts in the venules. The hallmark of acute inflammation is increased vascular permeability or vascular leakage. In normal condition, a minute amount fluid may leak, but when in inflammation there is some change. Look, the dormants of blood vessel known, you know, Sohail Babul. No, these are the dormant called endothelial cells. They are very strict and no gap in between the dormant. Due to inflammation, there are some mediators from the site of injury like histamine, bradykinin, leukotrienes and other chemical mediators which activate the endothelial cell. Activated cell cause the junction core or the groupings become weakened. The weak junction or injured site enables the solid particles of the blood like protein molecules, antimicrobial chemicals and cellular components like Shomukustigir, which is squeezing through the doors. So, vascular permeability normal and increased in case of inflammation, which ultimately cause the fighter within the train to the site, and now it permits the fighter to go to the site of injury to fight with the offender. So, how the endothelial cell or the domain become permeable? The cell contracted or junctional retraction occur. A direct endothelial injury due to immediate or sustained response. When leukocytes accumulate on their wall, they become injured, transcytosis may occur. When the process occurs, the endothelial cell become permeable. In normal condition, no permeability. The fluid, the molecules, the cells, all are within the circulation. But here, you see, this retraction may be immediate or transient, that is rapid and short-lived, or may be long-lived due to hours or days. It depends on type of insult. When there is burn or more lytic bacterial injury or direct injury, which takes more time to heal, to reduce the gap, the time is prolonged. Direct endothelial injury cause necrosis and detachment. It results from severe injury like burn. So it may occur in case of burn patient. It occurs immediately but lasts until the blood vessel repairs. Leukocyte-dependent endothelial injury. When the cell accumulates along the wall, it causes some injury on endothelium due to release of proteolytic enzyme. Showing various types of insult with various duration. Now the cellular events. During the first event within the blood vessel, only the fluid particles came out. So, the blood containing the solid particles, especially the leukocytes, normally RBC flow axially where the leukocytes peripheral. During stresses, more amount of leukocytes take peripheral position, known as margination. During this time, the endothelial cell become more activated and shows some receptors to bind with the leukocytes, which cause rolling and adhesion. And the injured cell permit the cell to leave the circulation, known as transmigration. Then chemotaxis, diapedesis, chemotaxis, and further event occur. Slowing, concentrated RBC, peripheral distribution of the leukocytes, leading to rolling, adhesion, and transmigration. margination. So, when more white cell leukocytes check peripheral position along the endothelial surface, known as margination. RBC in the center, whereas leukocytes take peripheral position. More leukocytes. It is not normal. It occurs in case of inflammation, known as margination. Now look, some cell away, some trying to penetrate. Endothelial cell shows selectins and some mediators. Due to selectins, the accumulated cell peripherally positioning cell roll and bounce again and again on the surface of endothelium due to weak bondings of selectin. When bound with integrins, this is more strong bondings, so adhesion occurs. Ultimately, transmigration, chemotaxis. Imagine when detached and bound again and again, it is rolling. When tight, adhesion, finally to the side is adhesion and transmigration. Adhesion, rolling, diapedesis, chemotaxis, and phagocytosis. So what is rolling? It is due to selectins. Bounce or roll along the endothelium due to selectin. Selectin form weak bondings, and integrins like cellular adhesion molecules form more strong bondings. Selectins. Various types of selectin you know. E-selectin, L-selectin, and P-selectins, all responsible for rolling. E-selectin, P-selectin, and L-selectin, L on leukocyte, E on endothelium, and P on platelets. Rolling, then adhesion. Adhesion mediated by intracellular adhesion molecules or vascular cellular cell adhesion molecules. Firm adhesion. Now transmigration. Now the train reached the site of offense. So the fighters are ready to go the site. And dormants almost ready assisting the leukocytes by lateral endothelial cell adhesion molecule and intracellular adhesion molecules. To leave the cell to the site of dormants, trying the fighters to leave the cell from the train. And cell also trying to go out, though it is not a usual place. From the barrack, they come out to fight. How? What will they do? In the station, there are a receiver for them. There are complements, arachidonic acid metabolites, and other chemokines, cytokines, and bacterial products to receive the cell. They'll receive the leukocytes, take him to the final site for fighting. The accumulative receiving or locomotion along the chemical gradients, according to pathology, known as chemotaxis. Going there, what will they do? The leukocytes will more endowed themselves and finally fight with the offender agents. The final fight we discuss, inshallah, in the next class. Students, remain healthy and stay at home. If any question, write down in our comment section. Thanks all.